Here's another example of a rational equation. We need to clear out the fractions, which means we have to pick the right multiplier that will cancel all the denominators when we multiply everything through by that quantity. Let's factor this trinomial so that we can identify the factors that are there that we could use to cancel that trinomial. Again, wouldn't I like to have at least one or maybe both of those work for me? And again, in this case, they do. X times x is x squared. Minus 4x minus 2x more is minus 6x, and minus 2 times minus 4 is plus 8. This trinomial factors into those two binomials. So again, I'll use those two binomials as the multiplier, because then that will cancel that denominator completely, just leaving me negative 2 times the quantity x minus 6 there on the right side. But if I use that pair of binomials as my multiplier, I'll have to multiply this side of the equation by the same quantity. So here, the x minus 2 binomials cancel, leaving me x to be multiplied times the quantity x minus 4. Let's go ahead and put it down since I didn't do the multiplication over there yet. Here, the x minus 4s will cancel, leaving me plus 3x to be multiplied times x minus 2. Now we can go through and remove the parentheses. X times x is x squared minus 4x plus 3x squared minus 6x equals negative 2x plus 12. Let's combine the like terms that are here on the left side. X squared plus 3x squared, that's 4x squared, minus 4x minus 6x more, that's minus 10x. And it appears we have a quadratic equation, doesn't it? Let's bring these two terms over and put it in standard form. So we'll have 4x squared. If we add 2x, isn't that going to give us then negative 8x? And we'd have to subtract 12. Now, I could use the formula here, but before I use the formula, there's something I notice. Isn't each term here divisible by 4? So couldn't I divide both sides of this equation by 4? 4x squared divided by 4 is going to give me x squared. Minus 2x, 8x divided by 4 is 2x, minus 3 equals 0. 0 divided by 4 is still 0. Oh, now that trinomial is worth me looking at to see if it's factorable. That's a pretty simple looking trinomial. It'd be nice if it was factorable. So let's move it over here and just see if it is. If it's not, we can take a minute or two. If it's not, we can use the formula. But I have a feeling this one will be. To get a minus 3, I've got to have a plus and a minus. And how about if we put the 3 there and the 1 there? X times x is x squared. Minus 3x plus 1 more x is minus 2x. Plus 1 times minus 3 is minus 3. And our two solutions here are x equals negative 1, x equals 3. Oh, I wonder if either of these solutions are the restrictions on x. So let's go back and check out the restrictions on x. If x was 4, wouldn't that denominator disappear into 0? If x was 2, wouldn't that denominator disappear into 0? Neither of which I can allow to happen. So those would be the restrictions on x, 2 and 4. And neither of my solutions are restrictions. So I feel pretty confident that I'm good to go as far as that's concerned. Of course, I wouldn't know if they were right until I plugged them in to see that it made the left side the same as the right side.